When you use a clamp-on ammeter to measure current on a three-phase load, you are primarily reading information related to apparent power, which is expressed in kilovolt amps, or KVA. To understand why, let's break down the concept of kilowatts, or kW, and kilovolt amps, or KVA, in three-phase systems. Kilowatts represent the real power being used by the load, the power that actually performs work. It's the power that shows up on your utility bill as energy consumption. Kilovolt amps, on the other hand, represents the total power flowing in the circuit, including both the real power and the reactive power. Reactive power is the power required to establish and maintain electric and magnetic fields in inductive loads such as motors and transformers. Inductive loads cause the current and voltage waveforms to become out of phase. This phase difference is expressed as the power factor, which is the ratio of real power, kW, to apparent power, KVA. Formula is power factor equals kW divided by KVA. A power factor of 1 indicates that the voltage and current are perfectly in phase and all the power flowing in the circuit is being used to do work. A power factor less than 1 indicates that some of the power is reactive and not contributing to actual work. A clamp-on ammeter measures current, not power directly. To calculate kW, you would need to know the voltage, current, and power factor. For a balanced three-phase system, the formula to calculate kW is square root of 3 times voltage times current times power factor. However, a clamp-on ammeter only gives you the current reading. To calculate KVA in a balanced three-phase system, the formula is simpler. It is the square root of 3 times voltage times current. Without knowing the power factor, you cannot directly determine kW from the clamp-on ammeter reading alone. You would need additional information from a power quality meter or other instruments that can measure power factor. In summary, while a clamp-on ammeter is a valuable tool for measuring current, it directly gives you the information needed to calculate KVA. To determine kW, you also need to know the voltage and power factor of the three-phase system. The voltage is usually known. It would be something like 208 volts, 480 volts, or something similar. The power factor must be measured by other methods to convert KVA into kW. Therefore, using a clamp-on ammeter alone will provide you with data to calculate KVA, not kW, without additional information.